Okay, so the first thing I want to do is measure the voltage out of this power supply. 42 volts at 1000 milliamps or 1 amp. Let me go ahead and plug it in. It's turned on. And I see 42.51 volts. 0 amps. I don't have anything turned on. Let's turn on a load. So there is 1.035 amps load, and the power supply pulled down to 42.14 volts. Now if we increase the load, the current stays the same. So this is a constant current output power supply, but the voltage did drop down to 36 volts. So I'm sure if I apply more load and more load, it will limit the charge current to only 1 amp. But as you can see right there, 1.035 amps and 42.1 volts output. So the power supply is working perfectly. Evercross. It's a scooter. I don't know if I can zoom in on it, but it's folded. So there's the front wheel, there is the back wheel. And then down here, if I can avoid not knocking absolutely everything over, there is the data plate. Let me zoom in on it one moment. All right, so there is the data plate. Electric Scooty. Battery capacity 6 amp hour. Output DC, that must be the charger, 42 volts, 1 amp, because it's motor power 350 watts. Charging time 4 to 5 hours. Max speed is less than 12.4 miles per hour. Max loading less than 220 pounds. It weighs 27.6 pounds. Manufacture year 2022. But there is all of the data. So the problem with this thing is it don't work. When you do charge it, it goes for a few minutes and then it just stops. So need to figure out what's going on. I suspect batteries possibly. So I'm going to go ahead and put this on the charger and see if it draws current. I'll bring the kilowatt out. We'll plug it in and measure the current through the kilowatt and see what it has to say until it's fully charged. And then I will daringly take this thing for a ride and see what it does. One moment. Okay, so there's the kilowatt. Let's power this on. Make sure we have 120-ish volts, and we do. We get a green light on the charger. I have not plugged the charger in yet. Let's just go ahead and step this over to, if I can see it, let's just put it on watts for the heck of it. And let me move it so I can actually see it on the camera. Okay, that should be good. So I'm showing 43.5 watts. Let's look at some other interesting items. VA of 73. So what's that going to be? Power factor of about 0.6. Yes, 0.59. So we're drawing 0.59 amps and 43.7 watts. Well, I'm going to let this thing charge until that light turns green, and then we'll try to ride it. One moment. I'll come back when this thing finishes charging. Well, that could have been more than 1 or 2 minutes, but it says it is done charging. So try to unplug it and plug it back in. So I'm probably going to have to switch over to an alternate camera to show any more of this. So I can try to unfold this thing and power it on and see what it does. But I guess it only goes for a few feet before it's totally dead. So let's give it a try. One moment. Okay, let's try to power this thing on. There's a power button here. And I hear it clicking, but I never get anything out of it. I don't believe this has a power switch. And it will not turn on at all. I wonder if I plug the charger into it, if it will power on briefly. Okay, I have my kilowatt out here in the hallway. And we'll go ahead and pop that cover off and plug the charger in. And I still see 0.0 and a light, but will it allow it to turn on? And I still get absolutely nothing. Well, I think the first thing we need to do is open this thing up and check the batteries in it to see what condition they're in. Pretty sure they're lithium ion, probably 10 cells. if it's rated at 42 volts, and that's what that charger puts out, is 42 volts. So if you tip this thing upside down, down here on the bottom, there's, I think, about either 12 or 16 screws that removes the bottom plate. And we'll check the battery voltage and see what it has to say. One moment. All right, well, here is the bottom of the scooter, and if I can slide it around, it's gone off a curb a time or 6. So let's go ahead and pop these screws out of the bottom and see what lives up inside here. Unfortunately, I'm going to have to pause the video while I take the screws out. One moment, once again. You may hear voices in the background. Normally, I'm not working in the daytime when my family's up, but my family is up right now. So anyhow, I got this thing open, and then there's the little generic controller for the DC brushless motor. And there is the battery. Look at the size of this thing. Let me just kind of scoot it along the workbench right there. Lithium-ion power battery pack. So it had heat shrink over this. I believe this is the charge cable, and then this is the load cable. So I'm going to go ahead and just unplug this, and then I'll flip it over and we'll measure the voltage and maybe put a load on the battery and see what it has to say. One moment. Okay, here is the connector for the battery. And I don't know what's positive and what's negative at the moment, so we'll just go ahead and probe up on it. And I'm seeing 1.9 volts. It was 2.3. What about if I put a small load on it? 0.1 volts. That's going to be a problem. That's going to be a big problem. Let me plug the charger back into it and see what it does. One moment. Okay, I went ahead and switched meters and got the charging cord right here. All right, power has been applied to the charger. And I did see a change for one moment. So let's put this on the 60 volt range, and we'll put it on min-max. I'll power this thing back down. It still shows voltage. Waiting for the green light to go out. And there it finally went out. We'll power it back on. Once again on min-max. Light just came on, and it went up to 5.4 volts. So I'm definitely going to say we have an issue with the battery, which lives right here. Let me see if I can get it out. I doubt it's disassembly ready. Looks like it's pretty well contained in there. So one moment, let me see what happens when I try to pull this thing out. So just for the heck of it, I thought I'd try to jam my leads down in here and make sure that we do have charge voltage on the plug. And we do have 42.5 volts on the charge plug. So I know that's good. So I definitely have a failure in the lithium-ion pack. Okay, let me try to get this thing out of here. One moment, once again, twice again, third time again. Okay, so I have the battery pack out of the unit. Just those two connectors, the charge and the output connector. And it's got this heat shrink over it, so I'm just going to try to slice it open and gain access. See if we can get into it. I think I'll start from the bottom. And it just looks like a bunch of lithium-ion batteries and a circuit board, possibly. Wonder if I can get the tape off. Nope, I'm just going to cut it. Doesn't work now. It's not going to really hurt it. Oh, there we go. Look at that. I don't see a board on the bottom. Definitely could have populated this with more batteries if they wanted to. Try to get all this tape off of here. And quite a bit going on. Looks like they definitely have charge balancing, which is very good. I wouldn't have expected that, honestly. So I wonder if we can actually read the battery voltage of each individual pack or pack of cells. So it looks like, I can't tell. So one pack and maybe half of another one, and then they're combined. So I'm guessing 1, 2, 3, and then half of this one. I don't know. And then 1, 2, 3, and half of this one, and then 1, 2. I don't know. Okay, let's go ahead and look at this thing and measure some voltages and see what it has to say. Okay, well, I spent a few minutes trying to figure out what they're doing here in this battery pack. And I wanted to be able to measure each individual, let's call them banks of cells. And so what I came up with is a car headlight right here. And at 4.2 volts, it draws about 2.5 amps. And so I found that, we're just going to put this on here and hopefully you can see the light. There's one bank, and I read 3.4 volts. And then this is another bank right here, and it reads 4 volts loaded. This is one other set, 3.3. I think I slipped and it touched something brighter. 3.3 volts. This is the next bank, we'll call it, 3.6. Next one, 4.0. And 3.9. This one's only 2.2 volts and dropping quickly, so it tells me that is going to be a problem. 2.8. And then on the last bank, we've got 4.0. Straighten out that lead. And we have 4 volts. So a couple of very weak cells. I'm suspecting that probably the balancing circuit is not adequately charging a couple of these cells, or they're just cheap Chinese cells. I mean, the thing says it was made in China. So would you expect any more? Let me try to get a close-up on those cells if anyone recognizes who actually built these. Let's get back into the automatical focus here. So SY INR 18650, 2500 milliamp hour, 3.7 volts, nominal obviously, and 9.25 watt hour, and the date code of 22H03, which might be the third week in 2022. I'm not sure. March 22, and the H is a week code. I don't know. But I'm going to pop up a couple screenshots right here. I found from the original manufacturer, you can source a complete replacement battery for this thing for $79.99 US dollars plus shipping. And as you can see, it's free shipping. So it's not worth it for me to try to resell this thing and to find out that we have some kind of a weird issue on the balancing circuit over here. I just went ahead and ordered a replacement battery. This scooter happens to be for one of my grandsons. You saw one of the other ones where I repaired his, let's see, what was it, a Scepter TV, and people made a comment that I called it a cheap Chinese TV, and immediately grabbed a remote from my personal Scepter TV that I have. Yes, I have several cheap Chinese TVs, as long as they work. So anyhow, that's where we're going to end up at the moment. So it does have a fuse that says 30. Is that 30 amps? I'm not sure, but that does interrupt the negative power lead. And then this little fuse right there with the letter S, I do believe, interrupts the charge current, which is, I believe that's the charge controller right there. And then these are some of the balancing or output FETs. I don't know. If anybody recognizes anything, let me know. I don't see, well, I guess there is a number on this chip. One moment while macro zoom is enabled. All right, macro zoom has been enabled, and then there is one of the chips. Cell-wise, CW1053 is the part number on the chip. And, oh, wrong way, dumbars. There is the other chip, and once again, it is a cell-wise CW1053. So I could certainly take a look at probably the nomenclature that the manufacturer put out, a data sheet, so to speak. But I'm not really seeing any issues, just doing a quick glance at this board. Try to get up to where the 4 FETs are. I would imagine these are probably in parallel for output current control. And you just barely make out the number on them there. 6888K, and I'm pretty sure that is a date code, R06210J. And then this is just a Schottky diode, most likely. There are the two fuses, a 30 and an S. They both check perfectly fine. And once again, a 6888K. Don't see any damaged parts. Don't see any smoke stains on the board anywhere. Everything looks absolutely perfect. So I'm just going to go ahead and order that $79 battery, and hopefully that repairs my other grandson's scooter. All right, well, that is going to be it. Everyone, thank you for making it to part one, or making it through part one, I should say. And once the battery comes in, I will insert it, charge it, and hopefully this thing will be back on the road literally once again. Everybody have a great day. Thank you so much for watching. I really appreciate it. Bye-bye. So this is an addendum to the intro right here. So as you can see, this is the connector for the power supply. I just have a wire shoved into the end of it right there. And so if you follow the positive lead, it goes to this red wire, which goes to this 100 watt 12 ohm resistor, and then through that to this green wire that goes through a 50 watt 6 ohm resistor, and then through that green wire over to this, and then that ultimately goes through a 10 ohm 25 watt and another 10 ohm 25 watt that I can selectively put in or out of circuit. So now the circuit is open, there's no load, and so what do we have? We have 12 plus 12 plus 6 plus 10 ohms. So I'm not good at math right now, I'll have to figure that out, but we can do some simple calculations to determine what is the resistance based on the voltage and what current we should expect over here. Now there's going to be a little bit of resistance in these leads. These are the Harbor Freight leads. I have soldered all of them, so they should have a very good connection. So basically, if you add all the resistance values here, it should come up to 40 ohms right now, unless I turn on the second load resistor, and then it's going to be 35 ohms. So let's do a quick load calculation with the Ohm's Law calculator. So we want to measure current, and so we know E and R, basically. E is the voltage, R is the resistance. So we'll put in 42 volts here, and then 40 ohms right here, and then we will calculate 1.05 amps. Hopefully you can see that is what we should see, and it's very, very close. Of course, I have those both on right now. So 1.05, whoops, somebody else, 1.05 amps. You know, pretty close, 1.03. Now, if we change this value right here to 35 ohms and recalculate, then we have 1.2 amps. And so the power supply is actually limiting the current to 1 amp. And when I turn on the second switch, it stays exactly the same current-wise, but we drop the voltage down to 36 volts, which is what it would take to achieve that 1 amp output. So I'm going to say the power supply is working perfectly. So I know somebody's going to ask, what is this contraption that I made? So it's a heat sink from an Allen Bradley VFD. I believe it was a 1336 VFD, if I'm not mistaken. Anyhow, it had some issues. It got scrapped out. So I took it and chucked it up in the Bridgeport lathe, and I just basically fly cut this till it was flat. And then I drilled and tapped a bunch of 440s so I could mount these 100 watt resistors down, because they do require cooling. And there is heatsink compound under each one. You can kind of see it oozing out there. And that gives me the option of either selecting or deselecting various resistors in circuit, so I can have a high power dummy load to test power supplies and whatnot. So I've got some 5 ohm resistors here, and then these are 10 ohms, these are 6 ohms, and then all of these are 12 ohm resistors to be able to test various power supplies. I was using incandescent automotive bulbs, but those have much more of a startup current or an inrush that needs to light the filament before the resistance actually comes down. So I went to these non-inductive resistors. I believe they are inductive, but still they're a constant resistance regardless of temperature of the filament, basically. Okay, here we go. Trying to power up the scooter. Check, check, check. Okay, well, there is the control panel for the scooter. And really right now? All right. Well, focus. You fuck. Focus. Really right now? So it says minus B and plus B. So we'll put that on volts. I get 37 volts, 22 volts, and 8 volts. That doesn't make any sense to me. I'm going to have to figure out how these things are basically constructed. Do some ohmmeter checks and see what is going on with this thing. All right, so I think I have it figured out. So if I measure between here and here, I've got 4.1 volts. You can see it there. And then between this side and this lead, there we go, I've got 3.6 volts. So that's a little bit low. Between there and there, 4.1, 4.1, and then 4.1. Oh, these are common, I believe. 4.1, and then they're in series for 8 volts. Hopefully you could see that. There you go, 4.1, 4.1, and then series for 8 volts. So for some reason it doesn't like that 3.6. Might be out of the range of what it likes to see. That, or it's just some of these controller parts have just gone south. So I think at this point, I'm just going to see if I can take a look at that model number right there, SY3606, and see if I can find someone who has a replacement pack.